Welcome back. So today we are going to solve all the questions from Ellipse which came in Jan 2025 sheets. In Ellipse we have total 7 questions, out of which 2 are easily doable, 3 are moderate and 2 are easy but lengthy, which we are going to solve. And this difficulty level is based on my perception, which may be different for others. So let's move on to our first question. Here is our first question now. Our question says the equation of the chord of this ellipse whose midpoint is 3, 1 is which of these equations? So to find the equation of a chord with a given midpoint, we have a formula T is equal to S1. So from here we will get T will be x into 3 upon 25 plus y into 1 upon 16 is equal to minus 1. Minus 1 is equal to, we will put the point 3, 1 in the ellipse. 9 upon 25 plus 1 upon 16 minus 1. Minus 1 will get cancelled. Minus 1 will get cancelled. Now we will cross multiply here. We will get 48x plus 25y is equal to, now 9 times 16 will be 144. 144 plus 25 will be 144 plus 25. From here we will get 48x plus 25y is equal to 169. From here our option A is correct. And here is our solution, and we can see that our answer is correct. Now here is our next question. It's based on the same logic as the previous one. Here our question says, if here we have is equation of the chord of this ellipse whose midpoint is this, then alpha plus beta is equal to. So again in this question we are going to use the same formula to find equation of a chord from a given midpoint. T is equal to S1. We will get x into 5 upon 2 divided by 9 plus y into 1 upon 2 divided by 4 is equal to 5 upon 2 square upon 9 plus 1 upon 2 square upon 4 and minus 1 both sides. Minus 1 is equal to minus 1. Again minus 1 will get cancelled. Now here we will multiply both sides by 9 into 4. So we will get x into, this will be 20x, 9 into 4, sorry, this will be 10x plus 9 into 4 here, this will be 9 by 2y, and this is equal to, from here again we are going to multiply by 9 into 4 to the right hand side. Here our 9 will get cancelled and 4 will also get cancelled. So we will not cancel 4, we will write 25 times 4, 100 upon 9, and 9 times 4 with this fraction will be 9 upon 4. When adding those two fractions, we will get 109 upon 4. Now we will multiply 4 both sides of the equation. We will get 40x plus 18y is equal to 109. So from here we will get alpha is equal to 40, beta is equal to 18. From here alpha plus beta is equal to 58. And our answer is option A. Here is our solution and we can see that our answer is correct. Here is our next question now. Our question says the product of focal distances of the point this on this ellipse where A is greater than B 7/4, then the absolute difference of the eccentricities of two such ellipses is. So first of all, let's say we have a ellipse. And there is a point P on this ellipse. This is focus 1, focus 2. Now this distance will be A minus E into x. Suppose this has P has coordinate x comma y, and this distance will be A plus E into x. So from here we will get A minus root 3 E, A plus root 3 E, product of focal distances of the, now this point is on this ellipse, this is given in the question, and product of focal distances is equal to 7/4. From here we will get A square minus 3E square is equal to 7/4. We will multiply 4 both sides. 4A square is equal to 7 plus 12E square. Now we will put this point inside this ellipse because our point lies in the ellipse. So this will be 3 upon A square plus 1 upon 4B square is equal to 1. Now our B square will be in this ellipse where A is greater than B. It will be A square under root of, A square 1 minus E square. So from here we will take A square to the right hand side. We will get 12. 1 minus E square plus 1 is equal to, now we will take 4 to the right hand side and A square is as it is. Denominator will also go 1 minus E square. Now from here we will use the 4A square, so this will be 13 minus 12E square is equal to 7 plus 12E square into 1 minus E square. Now solving this equation forward, 13 minus 12E square is equal to, let's open this, we will get 7 minus 7E square, 12E square plus 12E square and minus 12E raised to power 4. From this equation we will get 12E raised to power 4 and 12 plus 5 17 minus 17E square and 13 minus 7 6 is equal to 0. So from here we will get E square is equal to 17 plus minus under root of 17 square, which is 289, and 6 times 4 24 into 12 will be 8448. minus 288 divided by 2 times 12, 24. This is equal to 17 plus minus 1 upon 24. So from here we will get 3. 17 plus 1 will be 18. So both numerator and denominator by 6, we will get 3 upon 4 comma 17 minus 1 is equal to 16. Both numerator denominator by 8, 2 upon 3. So from here our E is equal to root 3 by 2 or 2 root 2 by root 3. So our required absolute difference means, let's say, root 3 minus 2 minus root 2 upon root 3 whole mod of root 3 by 2 minus root 2 by root 3. So from here we will get 3 minus 2 root 2, 3 minus 2 root 2 upon 2 root 3. So from here our option B is correct. Option B is correct. And here is our solution, and we can see that our answer is correct. So here is our next question now. Now here is one correction in this question. This is not an easy question. This is moderate. And same, this is not an easy question. This is a moderate question. So now let's come on to our next question. Here is our question. Now our question says, let E1 is this ellipse be an ellipse. Ellipses EI are constructed such that their centers and eccentricities are same as that of E1, and the length of minor axis of EI is the length of major axis of EI plus 1. I is greater than equal to 1. If AI is the area of the ellipse EI, then we have to find the sum of this infinite series is equal to. So this here in this question, first let's visualize what the question is trying to say. So let's say here we have our ellipse. So let's say this is our ellipse. This is our ellipse E1. Now the ellipse E2, length of the minor axis of E1, this is minor axis. This will be the major axis. This is the length of major axis for E2, and centers and eccentricities of E1 and E2 are same. So E2 should be a vertical ellipse like this. Please wait a minute. Now when we will come to E3, minor axis of E2 is major axis of E3. So our E3 will be ellipse, normal ellipse, and so on. So let's write our equation of E1. E1 is x square upon 9 plus y square upon 4 is equal to 1. From here we will get eccentricity is equal to under root of 1 minus 4 upon 9. So this is equal to root 5 upon 3. Now, our ellipse E2 will be x square. Now this is a vertical ellipse, so the length of major axis is unknown. Let's say this will be a square plus y square. Length of the major axis is the length of minor axis of even, which is 4. Now this is a vertical ellipse. 4 is greater than a square is equal to 1. From here, E is equal to root 5 by 3 under root of is equal to under root of 1 minus 4 upon a square. From here we will get 5 upon 9 is equal to 1 minus 4 upon a square. So we will get a square is equal to, please wait a minute. Yes, this will be a square is equal to 16 upon 9. Let me solve it. 4 upon a square is equal to, I am making some mistake here. 4 upon a square is equal to 4 upon 9. Please wait a minute. 1 minus under root of 4 upon a square is equal to under root of 5 upon 3. So 5 upon 9 is equal to under root of 1 minus 4 upon a square. So our a square is equal to 1 upon 9. I am making some mistake here. 1 minus 5 upon 9, 4 upon 9. Sorry, sir. This will be a square upon 4. A square upon 4. Smaller upon bigger. This is a vertical ellipse. Sorry for the mistake. It will be a square upon 4. So from here our a square is equal to 16 upon 9. Sorry for the mistake. I misunderstand this as the horizontal ellipse. So a square is this. This will be x square upon 16 upon 9 plus y square upon 4 is equal to 1. From here, this is our E2. Now E3 will be x square upon the length of minor axis is this. So major axis x square upon 16 upon 9 plus y square upon b square is equal to 1. So this is a horizontal ellipse. E is equal to root 5 by 3 is equal to under root of 1 minus b square into 9 upon 16. So from here this is equal to 5 upon 9 is equal to 1 minus 9 upon 16 b square. 4 upon 9, 9 upon 4 upon 9 is equal to this. We will get b square is equal to 64 upon 81. So from here our E3 will be x square upon 16 upon 9 plus y square upon 64 upon 81 is equal to 1. Now using this method we can find ellipse, but we have to find the area of infinite we have to find sum of infinite series. So there must be a pattern between area of E1, E2 and E3. So let's check it. Area of A1 is equal to pi into A into B, 6 pi. Area of E2 is equal to pi into 4 by 3 into 4 by 3 into 2 is equal to 8 by 3 pi, and 3 is equal to pi into 4 by 3 into 8 by 9 is equal to 64 upon 27. Not 64, 32. 32 upon 27 pi. From these, we can say that the first term is 6 pi of infinite series and common ratio is equal to 4 upon 9. 4 upon 9. Now our 5 upon pi times sigma I is equal to 1 to infinity. I is equal to 5 upon pi into A upon 1 minus r, which is 5 upon 9. 9 into 6. Now here pi will get cancelled, 5 will get cancelled. 9 into 6 is equal to 54. So our answer is equal to 54. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, let the ellipse E1 be this, where A is greater than B, and E2 be this, where A is less than B, have same eccentricity 1 upon root 3. Let the product of their lengths of their latest rectum be 32 upon root 3, and the distance between foci of E1 before if E1 and E2 meet at A, B, C and D, the area of quadrilateral A, B, C, D equals to. So here in this question, we have given some information about E1 and E2. We will use that information to find A, B and capital A, capital B. Then we will find the point of intersections. So same eccentricity product of there. Now we are going to use the information distance between the foci of E1 and E4. So distance between foci of E1 to AE. Now let's keep eccentricity of both E1 and E2 as E. 2AE is equal to 4. From here our E is equal to 1 upon root 3. So we will get A is equal to 2 root 3. Now eccentricity, we will find eccentricity of E1, which is 1 minus small b square upon a square, which is 12, is equal to eccentricity square, which is 1 upon 3. From here we will get 2 upon 3 into 12, b square is equal to 8. Now length of latest rectum of E1 is 2b square by A, and of E2 is into 2a square by B is equal to, this is small b and small b small a, is equal to 32 upon root 3. Now 2 times 8 upon 2 root 3 into 2a square by b is equal to 32 root 3. From here 2 will get cancelled. We will get a square is equal to 2b. Let me write this line correctly. 2 times 8 upon 2 root 3 into 2a square by b is equal to 32 upon root 3. From here we will get a square is equal to 2b. Now eccentricity, we will use the eccentricity. Eccentricity of E2 will be 1 minus a square upon b is equal to eccentricity square 1 upon 3. A square is 2b. Please wait a minute. A square upon b square. This is eccentricity this time. So from here a square is 2b. We will get 1 minus 2 upon b. We will get from here 1 minus 2 upon b is equal to 1 by 3. So from here our b is equal to 3. 1 minus 2 by 3 is equal to 1 by 3. Our b is equal to 3. From here our a square using this result is equal to 6. Now let's write the equations. Equations will be x square upon 12 plus y square upon 8 is equal to 1 x square upon 6 minus y square upon 9 is equal to 1. Now we will multiply this by 1 upon 2 and subtract these two equations. We will get x square upon 12 from both numerator denominator will get cancelled. This is plus, sorry. And with y square we will get 1 upon 8 minus 1 upon 18 is equal to 1 upon 2. We will get 9 into 8. 9 into 8, 9 minus 4, 5. And this will go there. 36 upon 5. Y square is equal to 36 upon 5. And from here our x square is equal to 36 upon 5. We will get we will put here 36, 4 upon 5, 1 upon 5, x square is equal to 6 upon 5. From here our coordinates, different x comma y coordinates will be root 6 by root 5 comma 6 upon root 5 root 5 and minus root 6 upon root 5 comma 6 upon root 5 and root 6 upon root 5 comma minus 6 upon root 5 and the other coordinate minus root 6 upon root 5 comma minus 6 upon root 5. Now these are our all the coordinates. Now we can see distance between these two and the distance between these two are same, and distance between wait a minute, let me say it again. Distance between these two and these two are same. Distance between these two and these two are also same. So our area of quadrilateral, now this is not a quadrilateral, this is a rectangle. So area of this will be A into B, 12 root 5, 12 upon root 5 into 2 root 6 upon root 5. So this is equal to 24 root 6 12 upon root 5 into 2 root 6 upon root 5. 24 root 6 divided by 5. From here we will get option D is correct. And here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says the length of the chord of this ellipse whose midpoint is this is. Now first of all, let's find the chord whose midpoint is given. T is equal to S1 x into 1 upon 4 plus y into half upon 2 is equal to minus 1 is equal to 1 upon 4 plus 1 upon 2 square upon 2 minus 1 will get cancelled. We will multiply both sides by 8. We will get 2x plus 2y is equal to 3. Now we will put the value of y from this equation in the ellipse to find the point of intersection. X square upon 4 plus 3 minus 2x upon 2 square upon 2 is equal to 1. From here, multiplying both sides by 8, we will get 2x square plus 4x square 4x square plus plus 9 minus 12x is equal to 1. We will get 6x square minus 12x plus 8. This is equal to 8. We are multiplying both sides by 8. Plus 1 is equal to 0. We will get x is equal to 12 plus minus under root of 120. 144 minus 24. Yes, divided by 12. Now we can say x is equal to 1 plus, first we are taking the plus 1. We can write under root of 120 upon 12 as root 30 upon 6, and the other x is equal to 1 minus root 30 upon 6. Now we will get y is equal to, if x is this, so y will be, using this equation, 1 upon 2 minus root 30 by 6, and in this case y is equal to 1 upon 2 plus root 30 by 6. So from here our required length is equal to under root of this minus this whole square will be 30 upon 9, and same here. So we will take 4 common from the 60, we will get 2 root 15, 2 by 3 root 15. From here our option C is correct, and here is our solution, and we can see that our answer is correct. Here is our next question now. Our question says, it is the same question as the previous one. Now this says if the midpoint of a chord of this ellipse is at this point, this is the midpoint, and the length of the chord is this, then alpha is equal to. So here again we are going to use the same process as used in the previous question. So t is equal to s1 x into root 2 upon 9 plus y into 4 by 3 upon 4 is minus 1 is equal to 2 upon 9 plus 4 upon 3 square upon 4 minus 1. Minus 1 will get cancelled. 4 will get cancelled. So from here we will get root 2x by 9. Root 2x by 9 plus y by 3 is equal to 4 will cancel the square of 4. This will be 2 by 9 plus 4 by 9, 6 by 9. This will be root 2x plus 3y is equal to 6. From here now we will take x and substitute in the ellipse. We will get 6 minus 3y whole square upon 2. This will be upon 18 plus y square upon 4 is equal to 1. So from here we will get please wait a minute. 6 minus, yes. Now we will take 3 outside, 9, 2, multiplying both sides by 4. 2 times 2, let's write it. 2 minus y square upon 9 will cancel 18 2 times plus y square upon 4 is equal to 1. 2 times y square plus 4 minus 4y plus y square is equal to 4. From here we will get 3y square minus 8y and plus 4 is equal to 0. So from here y is equal to 2 comma 2 by 3. Sum will be 8 by 3 and product 4 by 3. Yes. Y is equal to 2 comma 2 by 3. So our points will be, if y is 2, x will be 0 comma 2 or 2 root 2 by comma 2 by 3. Now distance between these two is our required length is equal to under root of 8 plus 16 by 9. So from here 72, 2 will get outside. So from here we will get 2 root 2 by 3. Now this will be 72 plus 16, 88. 88, we will take 2 outside. Sorry, 4 outside, we will get 2 root 22 upon 3 and 2 root 22 upon 3. From here our alpha is equal to 22 and please wait a minute. Length is equal to from here alpha is equal to 22. So our answer is option B. And here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.